All right, so we're going to do part 1. I break this up into 2 sections because it's easier to handle, and the way the old book that I like to use breaks it up into 2 sections too. So, part 1, we're going to classify polynomials. When I say classify, I mean name. I'm not spending a lot of time on this. You guys can catch up later. Determine the degree of the polynomial. We've already talked about degree. Degree is the exponent. You got to think of exponent. What's the top dog of the problem? Next, write the polynomial in what we call descending order. Highest to lowest. We'll talk about that in a little bit. We didn't get that in any of my classes yesterday. All right, here's the funny for today. See if you get it.
I just did one of those DNA kits and found out that I'm 90% gingerbread and 15% gumdrops.
5%.
Oh, 5% gumdrops. 3% candy.
All right, done. All right, real quick. Distribute 3 to everybody. So this is 3a squared. 3 times 6 would be positive 18a. And 3 times negative 2 would be negative 6. Then when you do the other side, you should distribute 6 to everybody and just write it down below it. So 6a squared, I'm putting like terms together, minus 6a. And then 6 times 4 is 24. So we add these up, we get 9a squared, because we got like terms together. So 9a squared plus 12a plus 18. All right, the next one. I'm going to skip this one for now. This one's not life or death. I want to go to this. All right, a monomial. A monomial can be, quit talking please. A monomial can be a number by itself, a variable by itself, or what's the word product mean? Multiply. Just say multiply. Yeah, you're right, but just say multiply. It can be a product of one of our variables. So I could have a number by itself, 6. I could have a letter by itself. I could have a combination of numbers and letters together as a product. I could have just all letters. I could have lots of letters. I could have A times B times C times D. But multiplication is the only operator that I use in a monomial. Mono means 1. Poly. Does anybody know what the prefix poly means? It means many. You guys will study prefixes next year. Many terms, okay? A polynomial, a monomial is a polynomial even though it's a single term. Poly means many, so when we start putting monomials together through addition or subtraction, then it turns into a polynomial of higher standing. It's not more important, it just has more terms. So in other words, monomials that are being added or subtracted together are what makes up a monomial. So right here I have plus sign, I have a minus sign, I have a plus sign. So I have 1 term there, I have 2 terms there, I have 3 terms there, and this would be my 4th term. We classify the polynomials. When you're told to classify something, whether it's in biology, math, whatever, we're asking you to give it a name. Name it. Put a name on it. So we already talked about monomial. Mono, the prefix mono means 1. A monomial is a 1 term. Bicycle, binomial means 2 terms. Hello? Sure can. Thanks, bye. You're leaving, Kinsey. All right. Trinomial, if you ride a bike with 3 wheels, it's called a tricycle. This is a trinomial. And last but not least, anything above a polynomial, or 4 or more is a polynomial. It's called polynomial. All right, polynomials. The only operators you can have on a polynomial are add, subtract, or multiply.
What was that last one?
Polynomials, 4 or more terms. This is all online. I'm going through it very quickly. All right, what's the degree of, all right, I don't need degree. How many terms are being separated by plus or minus signs? 2. Is it all addition or subtraction here? And multiplication? Okay, so yes, this is a polynomial. How many terms are there? 2, so it's a binomial. Good. right, the next one. Is there all addition, subtraction, and multiplication? Yes. So look at the plus and minus signs. So there's a term here. There's a term here.
It's 3.
There's another term. So it is a
Trinomial.
trinomial. All right, the next one. Is it only addition, subtraction, and multiplication?
No.
No, and it's not because there's division. It's because there's division of a variable. Because we're dividing by a variable, it's not a polynomial. That's what makes it not a polynomial. Because you could have 1/4 x squared. That still would be a polynomial. It's all right to divide by numbers. It's not, you can't have a variable with in the bottom of a fraction. All right, this last one. Is it all addition, subtraction, and or multiplication? Yes, so it is a polynomial. How many terms does it have? 1, so it's a monomial. All right, now we're going to go to degree. Now, I'm going to take you to crazy town with the degree, and then we're going to back it off after this unit. Like, we won't go crazy with this the whole time. We'll talk about degree like we did when I said, okay, if you're solving this equation, look at the power. What should be the answer? How many answers should we get? 2, but it was based on the degree. The degree is what told us how many answers we should have, okay? So, the sum of all the exponents of all its variables, because these are single terms. You're looking at one term only. So, for instance, I have examples over here. How many petunias and quilts are there over here? There are 7. So the degree is equal to 7. We won't do ones with multiple variables like this. I just go crazy on this first unit, and then from here on out, we won't use it again after this. How many elephants and donuts are there? No. 2. Degree is the exponent. You're focusing on the wrong thing if you're not looking at its exponent. So what's the exponent understood to be? Right here and here, once. So that's a degree of 2. What's the degree of this guy? Really? You need variables. Do we have any variables? No, so the degree is 0. Constants have no degree, and that's important to know. All right, now, we're going to do degree of polynomials. I know it sounds like we put it all together collectively, but that's not how you do a degree of a polynomial. A degree of a polynomial is the greatest degree, the top dog, the biggest degree, the biggest exponent of any term in the polynomial. In other words, find the degree of each term and choose the highest. You don't collectively put them together, you pick the biggest. All right, so this one, what's the degree of the first term here? What's the degree of the first term? 7. What's the degree of the second term? 3. What's the degree of this term right here? 4. What's the degree of this term? What's the degree with the number? Okay? Now, on this polynomial, you choose the highest. What's the highest degree? On this top one. I'm going to back up. We forgot to do it. What's the degree of this polynomial? So you look at each term individually, and you get 4.
Yeah, now you don't know who did it.
Yeah, I do. I can tell because I hear people saying the answer.
Dude, no, I don't feel like that.
Nope. Did you fill them out ahead of time?
I did. I want to go. And I like spit it out.
That's what it was?
Alright. Remind me to put a bonus point on your homework.
Okay, if I remember, okay.
Did you put a bonus point on?
Oh, boy. Right. Hey, you're
Alright.
Kind of looks like
Okay, so next one. If it is a degree of 0, it is a number by itself. What is a number by itself called? It's not the coefficient word, it's a constant. The number by itself. We already talked about this word earlier in the year. If it's a degree of 1, it would look something like this. Don't worry about, those of you that took the notes, I don't remember what I used as my example yesterday, so don't panic. I'm just going to do this. So it's a degree of 1. So x is to the first, y would be to the first. So what kind of graph would we get? All right, then we get something like this. And then we have a degree of 2. So what's this guy going to be? What's the name we use for a degree of 2? Quadratic. And then we're going to look at a degree of 3. So we got like something like 5x to the third minus 3x squared plus x minus 4. So what's that? I told you guys, remember dice. Cubic. All right, and then degree of 4 would just be like 6x to the fourth plus 5x to the third minus 3x squared plus x minus 4. And so what? Think of money. Quartic. And then last but not least, something to the 5th degree would have a 5 on the degree plus 6x to the 4th plus 5x cubed. They don't have to be this long. I just keep picking up what I already put down from the previous problems. And then what's 5 babies at once? 20. And then anything beyond that, we just name it by its degree. We just say 6th degree, 10th degree, 9th degree, 8th degree. We don't go any higher than that with the naming of it. So this is exponents, because we've done 2 names now. We've done exponent names. I can't spell exponents. We've done exponent names, and we've done term names. Well, how many terms are in it? All right, let's put that to use. Classify each polynomial. So this means to name it. Now, I'm not a big, you have to memorize these names for the rest of your lives. Who cares? No, it's not that important. But the reason why I push the names a little bit is, what if on the end of course test they go, using the quadratic trinomial, or what about, and the quartic polynomial, determine da-da-da. I don't want those words to throw you off, okay? So if they use that terminology, I want you to be okay with those words. It's not really a life skill you need to have. I agree. All right, what's the, we're going to classify, you're going to put the degree name first, and then you're going to put the term name second. Because the degree name is kind of written as an adjective already. So the degree name is constant. You have it right above. I don't have the chart on this page. Linear. Quadratic. I'm not going to write them all down, but, or cubic. I should have done cubic. Cubic. Quadratic, or, I did need quadratic. I was right. My brain's going in the wrong order. So linear, quadratic, I was correct. I thought I skipped one, but I didn't. Quadratic, cubic, all that. I'm not going to do them all, because I don't have enough room. And then when I say how many terms, you'd go monomial. Not momo. Monomial, binomial, tri, and poly. All right, so let's look at the degree first. What's the degree of the first term? What's the degree of the second term? 1. Now you all should be taking notes because this is all new. I didn't get to this in your thing. So if the degree is 3 or 1, which one do I choose? 3. Choose the highest. So the polynomial degree is 3. We choose that one. What's the third degree? Cubic. And then the terms are separated by the plus or minus sign. So count the terms around the plus and minus signs. How many are there? 2. So what's a 2-termer called? Binomial. All right, the next one. What's the degree of this term? 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 0. So 6 is our highest. What do we call that one? 6th degree. And how many terms are there? Look around the plus and minus signs. How many terms are there? 4. So what do we call a 4-termer? Poly. It's a poly. We don't name it after 4. All right, next. What's the degree on this guy? 1. So a degree of 1 is what? No, degree. Linear. How many terms do I have? And I have plus or minus sign, so there's only 1 term, so that's a mono. No. You're getting yourself confused. Keep those straight. 1's an exponent, 1's the terms. Okay. The omeals are how many terms you have, and then the x, the quadratic, the quintic, the cubic, all those are your degrees. All right, next. Order. Descending order is a big deal. From here on out, I expect you to put your polynomials in descending order. It'll help us for other things too. So descending order is exactly what it sounds like. You're going from highest exponent to lowest exponent. So the biggest exponent down to the littlest exponent. So go from big exponent to small exponent. So highest degree to lowest degree. Standard form is what you're doing. You're putting a polynomial in standard form when you go from highest exponent down to lowest exponent. Now, you do not have to have every term. So like if you have like 5x to the 5th, and then you don't have another term until 2x squared minus 3x plus 1, that's okay, because you're still going down. You're going down in order. So the degree on this guy is 5. The degree on this guy is 2. The degree on this guy is 1. The degree on this is 0. So you're counting down. But it's okay to have missing terms. Now when you get to algebra 2, sometimes you'll have to fill in those missing terms with just zeros to hold a spot for them. Because you do other things with these polynomials that I don't want to go into and freak you out. Alright? So degree of 5, degree of 2, degree of 1, 0. So it's in order, high to low. All right, leading coefficient. This is the line leader. Now, our line leader is a number only that's sitting in front of the guy with the highest power. That's what a line leader is. Because when you were line leaders back when you were cute and adorable, you stood out in front, right? You're in the front of the line. But when I ask for leading coefficient, I better not hear any x with it because it is just the number that sits in front of the variable. All right, so let's practice putting these in order. So I want to put this in order from highest exponent to low. You take everything that's with that power. You can't just like leave the number to the side. You take the whole term with it. So who's my top dog term? Say it carefully. Negative 7x. You cannot ignore that negative sign. Negative 7x to the 5th power. So we use that one. What's the next biggest dog? Positive 4x to the 2nd. Who's after that? What kind? Positive 6x. And who's last? Positive 9. All right, what's my LC, my leading coefficient? Who's the line leader? Ah! Just number only. Negative 7. Just the negative 7. All right, what should I do if I were I put this in equation format. I said y equals negative 7x fifth, blah, blah, blah. Which way would this graph look? What would the arms be on the graph? Negative 7x to the 5th. What would it do? It'd be opposite each other, but it's negative. Leading coefficient's negative, so what does that do to my graph? And then what is the 7 going to do to my graph? It gets it really skinny. Very good. Makes it really skinny. Okay? If this graph was 1 over 7, maybe be fat and wide. But if it's a whole number, it goes like this. Okay? All right, next one. Let's put it in order. So what's the order on this one?
Negative y to the 6th power.
Negative y to the 6th power. What's next?
Negative y to the 2nd power.
Positive y to the 2nd power. And then Negative 3y. What's the leading coefficient on this one? Negative what?
Y.
Ah!
Negative 6.
Oh, negative 1.
Number!
6. Wait. 1.
Negative 1. Guys, what's sitting right here?
A 1.
Negative 1. Alright, what's my arms going to do if I put this into an equation? What would it look like? Together, but it's a negative leading coefficient, so it's going to do what?
Oh, down. You messed up.
Negative means down. It's a 1 out front. Is it going to go or is it going to stay like this? Does 1 do anything to anybody?
No, it just stays.
It just stays. It just stays.
So,
Alright, here we go. Like I said, this unit's the only time I'm going to make you do these crazy degrees. Other times it'll be like a single variable and you only look at the highest power degree. Alright, what's the degree on this? How many M&Ms and nutmeg do we have?
8.
No, 8. Very good. 8.
Okay.
You count up all of the M&Ms. There's M times M times M, N times N times N times N times N. So there's a degree of 8. How many xylophones, yo-yos, and zebras are there all together? 3. Like I said, we will not do multiple variables outside of this first half of this unit. We'll go to single variable after that. All right. What is the degree on this term? No, right here.
Oh,
5. What's the degree? It's not 5 over here. I can tell you that much.
It's 6.
6. How do you do a degree of a polynomial?
Yeah. Not the bigger one.
Yes, you pick the bigger one.
6.
6.
You said add them.
Yeah, and then he said the bigger one.
You don't add anything. I know that's what your gut thinks you should
Well, then
do,
why'd you say that?
but I didn't say it. You said it.
You said, I said add, and then he said the bigger one. And
I
you're
said
like,
the bigger.
correct.
No, he said the bigger one. Never mind. You weren't together.
So
All right.
confusing.
So, on a graph, guys and girls, the bigger degree is the one that'll determine if it's like this or like this. Okay? The top dog, that's why you only look at the top dog, because that's the one that determines the shape of the graph. The others just help the graph kind of wiggle its way through. All right, so let's look at this one. So we choose the highest. So the degree of the polynomial is 6. All right, what about this one? What's the degree on this guy? How many xylophones and yo-yos do I have? 5. What's the degree of this term?
4.
What's the degree of this term?
0.
So what's the degree of the polynomial?
5.
All right, next. Write these in descending order. So what's the descending order of this one? What's the top dog term? Negative 6. You guys cannot ignore these signs. Negative 6x to the 5th. What goes next?
Negative 5x to the 4th power.
And then what's last?
Positive x to the power.
All right, leading coefficient is what?
-6. No, -6.
What's the degree? No x. Just you guys, coefficients are numbers only. Degree of this polynomial, what's the top dog degree? No, what's the degree? Degree is exponent, 5. All right, now let's name it. So it's a 5th degree. So what's 5th degree? 5 babies at once.
What?
Quintic. Quintuplets. Quintic. And then how many terms does it have? Look around the plus and minus signs. How many terms are there? Separated by the plus and minus. 3. So what's a 3-termer called? Think of a bike you ride. Trinomial. Yes. Gavin still rides his tricycle.
No, I don't.
All right. Okay, so the next one. He's in denial. All right, what's my top dog term?
I'm actually going to take Hunter up on my tricycle.
No. Negative x to the 3rd.
Yeah, sorry.
Plus 5x squared plus 2. You guys, look at the powers. We're thinking way too hard on this. It literally goes 3rd power goes higher than the 2nd power, which is higher than no power. All right, so this is a leading coefficient is what understood to be there? We just did one. Negative 1. What's the degree on this polynomial? Who's the top dog? 3. So the degree is 3. That's important because that's the one that tells you how many times you should get an answer. Not all of them combined. It's the top dog determines how many answers you should anticipate. Okay, the degree is 3. What's a 3 degree?
Trinomial.
Cubic?
Oh.
No, you're doing terms. Cubic, but now how many terms does it have? 3, so it's a cubic trinomial. All right, this last one. This last one is a ball. So I'm taking an object, I'm throwing it straight up in the air as hard as I can. Okay? I'll do it too hard. I'll probably bust my little tiles and they'll never replace them. So,
No, they will.
yeah, but you don't know. My custodian doesn't always replace them. So, anyways, here we go. This formula, we will actually, bless you, use more than just this one time. Oh, I meant not 6, but H. And I kind of want to get some stuff passed out, so we're going to try to multitask here. This is H of I. I'm going to break this down. We are in math class. All the math classes typically use customary units. So, like, you'll use
You might want to
feet
stop
per second.
recording.
You'll use inches, whatever it is.
You might want to stop.
Why? I'm still
Still
teaching.
talking.
I'm still teaching. I'm talking about this. Okay, go to the back of your notes real quick and go to the homework section. Change that 30 to a 10. So you're going to do every fifth from 10 to 75. What does every fifth mean?
5, 10, 15,
Well, start at 10.
10, 15, 20.
So you're not doing that many. I know I gave you some more to do.
Michael, that's okay.
Do 1, 2, and 3, and then do 5 or 10 to 75 every fifth.
But you start at 10 and now.
I do not want them put on that paper, though. I'm giving you a paper to write your answer so I can clearly see what you're saying as your answer. And I wrote the numbers on this paper, too.
Hey.
Are we allowed to write on both papers?
You know I on both papers, but the only one I'm looking at is this one right here.
Okay, serious.
Well, you're holding on to that line.
Yes, Ali.
Wait, do we count by tens?
5, 10, 15, 20, 25, 30. We start at 10.
Somebody help Gavin.
What is his
Listen here, Pooh.
He doesn't know how to go
Come
count.
here, son.
I'm confused on what we're doing.
Go. 1.
Okay, Gavin, let's make this easy. I have an easy right here to tell you what to go to. Number 1, right there. Number 2.
Okay, now, you said, look, I was looking at, I got it now.
Some people need extra.
Hey, real quick. What's the thing that's affecting this brain as I throw it up in the air?
Gravity.
Gravity. So if you guys take physics from Mrs. Beal, it will not be negative 16. I don't know why the textbooks of math always use customary units for the most part. This is the force due to gravity right here, this negative 16. And it is measured in feet per second squared. Okay, that's what this negative 16. You will never see that in physics class. It'll be negative 9.8 something, something, something. All right. What else is, when I go to throw a ball, what happens to that?
It goes.
Well, yeah, but what is it like that? What does it have on it? Speed. What's that word? Another word for speed. Velocity.
That's the word.
This is initial velocity. Okay, that's the initial velocity. And then H. So if I'm taking and I'm throwing a ball like this overhand, thank you, and I have Landon or like Bryce Hall throw a ball, theirs is going to be up here, right? Because they're in their 6 foot era. I'm only 5'9". So they're throwing it, they're coming off their shoulder. That initial height is going to be different. Football player. Where do I start off kicking the ball at?
On the floor.
On the ground, right? So the kickoffs are on the ground. Do I want to kick a punt off the ground? No, usually that's a bad idea. Okay, so this is the initial height of the object. Now, we have all gone outside. I don't care if you're not athletic. Don't tell me from baby when you toss a ball all up until now, you've never gone outside and thrown something, an acorn, something as hard as you could straight up in the air. That's what's going on here. Okay? So,
Have you ever tried to kick a rock?
what does T represent? Huh? What's T represent? Time and what? Seconds. Okay, we're going to see With this, what this formula does for us, it tells us how high an object is at a moment in time. So we're going to plug this in real quick. Negative 16 times 3 squared plus 80 times 3 plus 6. We're putting in 3 seconds because we want to know how high this ball is in the air after 3 seconds. This is, I'm going to do this very quickly. You can use a calculator, but we don't have time. 80 times 3 is 240 plus 6 equals negative 16 times 9 is negative 144 plus 240 plus 6. 246 take away 144 is 102 feet. So at 3 seconds, after 3 seconds, you've taken this ball and you went, wound up, and you threw it as hard as you could. It goes 3 seconds up in the air, really high, like a hard ball. This wouldn't go that high in the air because it's soft and squishy and it wouldn't have a much, needs a little bit more heavy, weight to it. All right, so that's it. And we changed our assignment to 10.
Can you do me a favor? Be a nice.
You got to change this to 10 if you didn't do that. Right here. It goes to 10.
Yeah, because I'm not.
We're doing 10 to
You might
75
wanna
every
stop
fifth.
recording now.
When is that due?
Friday.